geometry, we are sans my regular microphone pack because I left the battery on over the weekend. Thankfully, Jeff has been informed, and I will have new batteries delivered to my house tomorrow. But until then, I just need to talk really loud and close to the computer so you can hear what's going on here. But anyway, we're starting proofs, geometric proofs, things that you'll be using those postulates and those theorems for to defend each and every step. And essentially, proofs are all about answering two essential questions. Number one, what do I know? That is how you start every single proof, with what you know. That is your given statement. Yes, Alex?
Are we going to go through the homework? We already did.
We already kind of did. We're not going to go over each and every proof, no. What do I know? What's given? Okay? And the second question, the most important one, is how you're going to work through the proof. What can I conclude? Okay? Now, the word conclude comes from conclusion. Right?
You just said it.
What is it?
It's a word. You said it. You said it. You
Word?
said the word conclude.
Oh.
Yes! We're so good.
Can I see it?
There you go. That was a low suspense today. So the word conclude comes from conclusion, right? It means what can you? I lost my train of thought. It means what can you say with deductive reasoning? Okay, not just what can you see, because sometimes eyes can be deceiving, diagrams can be not drawn to scale. You have to know that you are concluding something. Okay, you are coming to a conclusion based on the information that's provided and everything you know. Rowan, do you have a question? Mrs. Field has waged war on my ceiling with 7th graders. She's telling them to bring in those, what are they called, sticky things, and throw them up there. Don't take them down; they don't bother me at all. But you may see more of them pop up.
My sister bought like 130.
3, 2, 1. You are quiet. Writing a geometric proof uses definitions, properties, postulates, and theorems. So all those theorems we talked about, all those postulates, those properties, definitions, all the wise old owls, all the key points, all things are eligible to be used to defend what you say in a proof. That's important to know. Okay? Those students who were most successful last year, they started like in a Word document or whatever, Word, started writing down these theorems, postulates, and so they just printed out for each and every test. They always had it. They had like kind of a running log, a running journal of all these things. They printed it out for each and every test, so they had everything the entire year, always at their fingertips for help sheets. And so today, we're going to go through several things you can add to your toolbox, and then we're going to practice some proofs at the end. Alex?
Can you just take out this page since there's
No, you need to recreate it some way, somehow yourself. Okay? Vince? Ellen, warnings for each of you. I'm sure you weren't doing anything, but Lexi, warning for you as well. Okay, the reflexive property of congruence basically says that, we'll use angles. Angle A is congruent to angle A. In a nutshell, it means something is congruent to itself. Okay? You think of the word reflexive, sounds kind of like reflective. You look in a mirror, you see what you see what's there, you see a reflection of yourself. Something is congruent to itself. As easy as this one seems, we'll use it a lot. So start that one. We'll make some sort of mark.
That looks like a flower.
Okay?
It looks like Olaf's
Angle A is congruent to angle A. Kelly.
Isn't that just like saying that that's just like the same thing?
It is. It's saying something's congruent to itself. And where we're gonna use this is with proving that triangles are congruent. I'm not gonna get too deep into it now, okay? But when we get to PO24, we're gonna use this a lot. So just trust me on it for right now. But it is saying something's congruent to itself. Okay? Damien,
I
Jeff,
didn't have a question.
What?
I didn't have
Okay.
a question. That's why-
The symmetric property for segments and angles, we'll use a segment this time, says that, well, we're gonna actually use an if-then statement. We'll say if segment AB is congruent to segment CD, then segment CD is congruent to segment AB.
Break that fast.
Okay? If AB is congruent to CD, then CD is congruent to AB. So where this came up last week, actually, when solving our equations, someone was solving a proof, and we had our x on the right side, and this person said the proof actually worked out to be x or 3 equals x. This person set it as x equals 3. The only way to do that is if we use the symmetric property. So it was like step 6, and we had 3 equals x because of the division property or something like that, whatever our last step was. It was probably that. In order for us to then say that x equals 3, we have to add a 7th step, write x equals 3, and defend it using the symmetric property.
We have to do this?
Yes. Okay? If you are going to switch something around on an equation, okay, write the equation the other way, you have to defend it using the symmetric property. Basically, if 3 equals x, then x equals 3. If AB is congruent to CD, then CD is congruent to AB. If you want to switch that around, you've got to defend it with the symmetric property. Damon, yes?
Then, is it always going to be like that this number equals x? Or is
It depends on what you're being asked to prove. Okay? Lisa, what is going on?
Catherine asked me a question.
Good to you go.
Hey, ask up here. I really can't be stopping class to if you got a question, please ask up here. There's too many notes going on. If you ask someone a question, now they miss something, now they're lost. They ask someone else, they miss something while they're answering, they're lost. There's just too much going on. If you've got a question, please ask me. Otherwise, people get lost throughout, and then it snowballs from there. I forgot what your question was.
B2.
Okay.
Oh,
I'm sure it was a good one,
got
though.
it. Is it always going to equal?
Oh,
Yeah.
it depends on what you're being asked to prove. If you were being asked to prove that x equals 3, and the way that you solved the equation, you ended up with 3 equals x, those are not considered the same thing in the proof world. Okay, if you were told to come up with this statement, x equals 3, and you solved it to get your 3 equals x, you would have to then use the symmetric property to switch it, so that your proving statement matches exactly what you're told to. Yeah. Okay. Aiden.
So you only have to use symmetric property if you are asked to prove that thing.
There are other times, but that's probably the one where it's mostly used. To where just the way that you solved it, the path that you took, you've got things on the opposite side that you need them to be, and so you just to switch it, then you'd use the symmetric property. It's got other uses too, but that's the prime.
This should be a key source right there.
What's that?
Symmetric property should be a key source.
It is.
Oh, that's what that means.
Obviously, it's a key.
Very good.
It's like maybe having them.
Anthony.
I just noticed this, but why are all the G's like that? All the G's are backwards. The G's.
Like
it's
congruent.
Oh, like
They're
like
fancy.
They're not very fancy.
Oh, they are backward.
Oh, they're
fancy G.
It's just how the G looks in the Times New Roman or Calibri font or whatever it is. Thank you for asking me that question rather than asking Max and having you both.
Max doesn't know.
That was very important.
Yes.
Yeah. The transitive property of congruence. We came across this one, if you remember back last year when we talked about the zero power property and how we defended that any base to 0 power equals 1. What we said was that if you've got something like n cubed over n cubed, we know that anything divided by itself equals what? 1.
0.
Okay? Anything divided by itself equals 1. we had just learned the dividing by the same base rule, which bonus points to who remembers what the dividing by the same base rule is for exponents. Catherine? Very good. Subtract powers. And so we had just learned that, and so we said, well, we also know anything by itself is 1, yes, but we also know that n cubed over n cubed, because you subtract the powers, is equal to n to the 0. Right? And so we defended this statement that any base to 0 power equals 1 by saying that if the same thing, n cubed over n cubed, equals 2 different things, these 2 things must be equal to each other. And at that point, I said, this is called the transitive property. And I wrote down, if A equals B and A equals C, then B equals C. And I said, don't worry about that now, we'll cover it in like a year in geometry. Well, that year has come up, and we're in geometry now, and here it is, right? The transitive property says that if the same thing, A, is equal to both B and C, then B and C have to be equal to each other as well. Okay? If A is B, you could also see it written out, if A is B and B is C, then A is C. That it's basically it's a way to relate 3 things, 2 of which you know are congruent. The third one's got to be congruent as well. Okay? This is another one, the star. There's a star. We'll use this one a lot. The transitive property.
More than the first one?
More than reflexive, I will say yes.
But you said that first one was going to be used a lot too.
This one will be used a lotter.
A lottery?
Not the one we'll use the lottest, but definitely lotter than reflexive property. The right angle congruence theorem says that all right angles are, Damien, warning for you. All right angles are congruent. It's aptly named. The right angle congruence theorem says that all right angles are congruent. It makes sense, but we have a theorem to defend it. Theorem to prove it. We don't have to prove that a right angle is equal to 90 degrees. If it's a right angle and it's another right angle, they're congruent. Okay? The congruence elements theorem says that if angle A is supplementary to angle B, and angle B is congruent to angle C, if angle A is supplementary to angle B and angle B is congruent to angle C. Okay, so let's just kind of take a look at what this might be here. Okay, we've got angle A. We'll say this is looks about to be 120 or so. Okay, we've got angle B, which we'll say is 60, thus making A and B supplementary, right? They add to be 180. Then we got this other angle over here, angle C, and we know that angle B and C are congruent. Finish this conditional statement for me. If angle A is supplementary to B and B is congruent to C, what conclusion can we make? Catherine?
Angle A and angle C are supplementary?
Yes, angle A, then angle A is supplementary to angle C. Okay? If angle A is supplementary to angle B and angle B is congruent to angle C, then angle A is supplementary to angle C. Or with angle C, maybe I should say. Questions? That'll get a little bit tricky, but hopefully with the pictures and the words it helps. Yeah.
Does that say angle A or CA?
Angle A. Sorry. I'll try and make my angle signs better. It's diagonal and straight across, but you know my writing. But yeah, it is angle. Yeah.
It's like this whole entire unit basically showing you're working with one.
Kinda. Yeah, pretty much. Pretty much. Yeah. All right, we're moving on to the next page. The congruent complements theorem says if angle A is complementary, I'll use with this time, angle B, and angle B is congruent to angle C. So let's see, here we've got like a right angle. Got two angles coming out. Here's angle A. Here's angle B. Do I need degree measures to show that these two angles are complementary?
Did you B like twice? Angle B and angle B.
If angle A is complementary with angle B, and angle B is congruent to angle C. So we're using angle B twice, yes. Angle B is kind of the connector here. Do I need degree measures here, though, to show that these two angles are complementary?
Probably
Why not, Christopher?
because you have a little box.
Because I got the right angle symbol, right? And then over here, we've got angle C, which is marked as congruent with angle B. What do we know is the relationship between A and C, Kylie?
A and C are complementary.
Yes. Then angle A is complementary with angle C. So basically the same thing as the congruent supplements theorem, only now with complementary angles instead. I said that we will use the reflexive property a lot. We'll use the transitive property a lotter. The one we'll use a lottest is right here. With 2 stars. The vertical angles congruence theorem. We've talked about vertical angles before. Okay? Because they're used a lot. And we know that vertical angles are congruent. That relationship is the theorem. Vertical angles are congruent. And so what are vertical angles? Well, they're vertical angles, or they're angles that are opposite each other at a vertex, at a point of intersection. Those two angles we know are congruent angles. Okay? These two angles we know are congruent angles. Right? Yes, Kylie.
So on the like side of the all of the theorems, what's the like little numbers in between them?
Oh, good question. So this is where in your book you can find them. Chapter 2, section 6, if you want more information or a better picture or something like that. Yeah. Chapter 2, section 6. Catherine. No, I've not had the announcement yet for this. Besides, that means you'd miss the rest of this, and I wouldn't want you to do that. Anthony.
What if the announcement never happens?
Yeah, it's never.
If we don't hear anything by 12:45, then I'll let you.
Then they won't get.
That's what
Yeah,
it
that's
is.
why.
They have to warm up. 'Cause they're cold.
I will call the office when we're done. But that means you gotta let me get through this. We'll give and take. Okay? Questions on this? Damien, turn up. Alright. Last one. Linear pair postulates. Okay? Oh, we'll use an if then. Same with if two angles form a linear pair. If two angles form a linear pair, then they sum to 180 degrees. If two angles form a linear pair, then they sum to 180 degrees. Right? So kind of the picture of this, you've got angle 1 and angle 2. They are a linear pair. There are two angles that make a line. Again, we've talked about linear pairs before for this reason. Okay, it comes up again in theorem form. But we know that angle 1 plus angle 2 has to equal 180 degrees. Okay. So far, these are the main postulates, definitions, theorems, etc., properties that we've covered. You should be familiar with all of these pretty much at this point. The segment addition postulate, the definition of a midpoint, angle bisector, angle addition postulate. Those postulates 5 through 11, which you don't have to know by name, right? But there's things like how many points does the plane have to have? How many points does the line have to have? Things like that. The properties of equality, addition, subtraction, multiplication, and division. Substitution was also in 0 to 15, and then all these from PO16. Tomorrow, we are going to dive into the gauntlet head first and start writing proofs for some of these different things. Okay? Shh. No homework for tomorrow. So, whoop, hold up. Oh, class is not over though. Hold up. No homework for tomorrow, so we can dive head first. I would like you to wait quietly so that I can call